Okay, two lines that are parallel have the exact same slope. We've already talked about this before. So if this is, for example, M1 and this is M2, the two different slopes have to be exactly the same because they have the same slant, the same rise over run. And we're going to use the notation double bars like this for parallel. That two double bars looking parallel like means parallel lines. So two parallel lines have the same slope. Two lines that are perpendicular. Perpendicular means they intersect, and they intersect at a 90-degree angle. Two lines that are perpendicular have opposite reciprocal slopes. So there's two changes to their slopes. They're opposites and they're the reciprocal of each other. For example, if this is M1 and this is M2, so whatever slopes they have, they are opposites and reciprocals of each other, which means if I multiply them, I'm always going to get -1. Again, they have to be opposites of each other because their rise and run is in different directions, and they have to be reciprocals of each other as well. And for perpendicular, we're going to use the notation like this. That means the two lines are perpendicular. Okay, let's look at these examples. Given the two lines, are they parallel or perpendicular? So I have line number 1 for part A and line number 2. So to figure out whether they're parallel or perpendicular, I'm going to analyze the slopes. And to get the slopes, I'm going to take each one and put it in slope-intercept form. So subtract x, and we're going to end up with y is equal to -x plus 2, it looks like. And then I'm going to take the second one and get it in slope-intercept form so I can see what the slope is. And it looks like I get a -x plus 5. So the slope of this guy, the first slope, is -1 over 1, I guess. And the slope of this guy, M2, the next line, is also -1 over 1. So these two lines are parallel. All we did was analyze the slopes. We'll do the same thing for part B. I've gone ahead and done the first equation. I've put it in slope-intercept form, and the y is now isolated. I'll do the same thing for the second one. So the second line here is also put in slope-intercept form. The y is isolated. Now we go analyze slopes. This is the slope of the first one. It's -2/3. And right here is the slope of the second line, which is a +3/2. So notice what happened. -2/3 got flipped and turned into a 3/2, and the negative also went away and became a positive. So if I look at these two and multiply them, -2/3 times 3/2, I do get -1. So these lines must be perpendicular. Again, the two slopes are exactly opposite signs and exactly reciprocals of each other, and I can check that by multiplying them. They always equal to a -1, so these two lines are perpendicular. Okay, let's look at another example. It says, find the equation of the line perpendicular to this line going through the point 1, 3, and give the final answer in slope-intercept form. So we already have a point for the line that we're interested in. The line we want goes through the point 1, 3, and the line we would also want the slope of that line to figure out what the equation of that line is. So what is the slope of that line that we want? We can get that by recycling or sort of using the slope of this other line that it is perpendicular to. So the slope that I'm looking for, if it is supposed to be perpendicular to this guy, has to be the opposite and reciprocal. So the slope that I need has to be a +3, and not only a +3, but the reciprocal of that number. So the line that I'm ultimately looking for the equation for goes through the point 1, 3 and has the slope of 1/3. And again, I sort of cheated and I said if it's supposed to be perpendicular to that guy, then I'm going to need to make it a positive and flip it and take the reciprocal and use that slope over here. Now I can use the point slope formula y minus y1 equals m x minus x1 with these two pieces of info. So y minus 3 equals m is right here 1/3, x minus the x value 1. I'm going to go ahead and simplify this because they want it in slope-intercept form. If they wanted it in point-slope form, I would stop right here and I would be done with this problem. But since it wants it in slope-intercept form, I have to go and distribute the 1/3 and then add 3 to both sides. So now I have y equals 1/3 x, and I have to combine these two guys, so we're going to go combine them on the side. I have a 3, which is positive, and a negative 1/3, so I have to get a common denominator of 3, that's 9/3 minus 1/3, which is actually 8/3. So it looks like the y-intercept here is going to be 8/3, and that's the equation of the line we were supposed to find. Now let's go check this graphically and see what happens. We already answered the question and we got the slope-intercept form of the equation we were supposed to find, but let's just go visually see what happens. So the original line that they gave us some information about was right here. We're going to go ahead and graph that. It's got a y-intercept of -2 and a slope of -3. So I'm going to go 1, 2, 3 down and 1 to the right. Or I'm going to go 1, 2, 3 up and 1 to the left. 1, 2, 3 up and 1 to the left. And we got our line. Now the other line that we were supposed to find, which we found right here, is 1/3 x plus 8/3, and that line came about because that line went through this point, 1, 3, and it was reciprocal to this guy right here. So let's see if visually that makes sense. The point 1, 3 is the line that I was interested with, 1 to the right, 3 up, and it was perpendicular to this line. So if it was perpendicular to this line, again we said its slope must go through this transformation of become positive and then become the reciprocal. So from that point the slope is going to be 1/3, which means go up 1, 3 to the right, up 1, 3 to the right. Or I could go down 1 and 3 to the left, down 1 and 3 to the left, and so forth. Now notice the two lines definitely do look perpendicular. The original one they gave me in green and the one that I just found by going through the ordered pair and the slope that I came up with, they definitely look perpendicular. And not only that, this equation that I have right here seems to match up with this line, because notice the y-intercept is actually something I can't really read. It's 8/3, which is 2 and 2/3, so around 2.67-ish is what that y-intercept is, which I wouldn't have been able to get visually because it ends up being an answer that's not a whole integer. Okay, let's look at another example. Find the equation of the horizontal line that goes through the point or the ordered pair 4, 6, and then also give this other information. It's x-intercept, y-intercept, and slope. So it goes through the order pair 4, 6, 1, 2, 3, 4 to the right, and 6 up, 1, 2, 3, 4, 5, 6. And the fact that it's horizontal, I'm just going to make a horizontal line through that. Now what is the equation of that line? We said horizontal lines have equations of the form y equals a number, and the number that it goes through is the y value 6, so the equation is y equals 6. What is the x-intercept of this line? Well, this guy never crosses the x-axis because it's parallel to it, so there is none. The y-intercept, it does cross the y-axis, and it does so at 6, so the y-intercept is 6, or in ordered pair form, 0, 6. And last, what is the slope of this line? Well, we talked about the slope of horizontal lines being 0. Okay, next example says give the equation of the y-axis. It seems a little bit vague, but we know what the y-axis looks like. The y-axis is right here. It's this line. So it's just a line, and since it's a vertical line, we know that it must be x equal to some number. Remember, vertical lines have equation x equal to some number. Well, what is the x value that this vertical line goes through? Well, here are positive x values to the right, here are negative x values to the left, and it's going through this x value that has a value of 0. So the equation for the y-axis is really this vertical line going through the x value 0, and its slope, not that they asked, but its slope, since it's vertical, would be undefined. So the equation for the y-axis is just a simple equation x equals 0 because it's vertical and it goes through the x-coordinate 0. Okay, so let's look at another example as an application. Flying lessons cost $6.45 for an 8-hour course and $14.25 for a 20-hour course. Both prices include a fixed insurance fee. Okay, we'll deal with that later, I guess, since they don't give us further info. It says express the cost of flying lessons in terms of the length h. So it's really going to be cost in terms of some garbage of h, which means this must be my y-coordinate and this must be my input x-coordinate. So part A says, what is the slope including units? So I'm just going to go make two ordered pairs of the form x, y, or h, c. Hours is 8, cost is $6.45, hours is 20, cost is $14.25. Again, it said c in terms of h, so it's c equals garbage in terms of h. That's how I know c has to be my y and h has to be my x. So we're going to go use the slope formula and find the slope. So we found the slope by plugging in y2 minus y1 and x2 minus x1 in the denominator. We found basically 65 over 1 to be the slope. It says include units. Well, the units upstairs were dollars because I was subtracting dollars, and the units downstairs was really the hours because I was looking at the difference of hours. What does it tell you about the problem? It basically says $65 per hour is, I guess, the course fee. Each hour costs $65 an hour. That's why 20 of them is $14.25. Maybe, maybe not, because actually there's a fixed insurance fee that we haven't really accounted for. So just the hourly cost of the course is $65 per hour is what it's telling us right now. Now, before I answer part B, I didn't really express the cost in terms of the length of the course because there was a fixed fee that I didn't really pay attention to. So let me go, by using the slope, find the equation of this line. So I'm going to use the slope 65 and the point 8,645 to find the equation of this line before I do anything else. It'll relate back to this as well. So I'm going to use the point slope formula, plug them in, and find the equation. So what I did was I chose to use the first ordered pair as my x1, y1, and the slope of 65 that I found. I plugged it into the point slope formula, I distributed, simplified, and then I made sure I changed my variables. Y for me was c, the cost, and x for me was h, the hours. So this is the equation that we ended up with, which will help us answer part B when it says how much does a 10-hour course cost. So I'm going to go plug in 10 for the h. So once I put 10 hours, the 10-hour course, into my equation, I got $775, the cost for 10 hours. Again, I didn't just multiply in part B the 10 hours by the 65 per hour because they told me there was an insurance fee that I didn't really know anything about until I found the equation. So I should have really found the equation first. Now part C we can quickly answer. How much is the fixed insurance fee? That must be this 125 that's sticking around in my equation, and I end up with C, $125. So no matter how much the hours cost, which is 65 per hour, there's always going to be a 125 fixed insurance fee. And the only way I actually found that out is by expressing the cost in terms of the hours, which gave me the variable cost per hour 65 and the fixed insurance fee of 125.